Good evening. My name is Christopher Anderson, and we're going to be doing discussion one today. We're going to start with the problem. Um, it goes as following. Scores on the SAT verbal test in recent years follow approximately the normal distribution with a mean of 505 and a standard deviation of 110. How high must a student score in order to place in the top 10% of all students taking the SAT? To figure this question out, we're going to go first over what we do know. We know that the mean is 505 and the standard deviation is 110, and the data is normally distributed. And since they went ahead and told us that the data is normally distributed, we're going to use the following equation. Z equals x minus the mean, all divided by the standard deviation. In the equation, the x equals the random variable, and that's what we're going to be solving for. Mu equals the mean, and sigma is the standard deviation. Since we already have the mean and the standard deviation, we're left with finding z. This can be done by using the normal distribution table. In order to find the z, we must first use the probability, which is p of z is less than or equal to small z. Since we're looking for the highest 10%, we must apply this by subtracting 0.1 from 1.0. And this is due to the fact that all numbers in the normal distribution table are less than 1. Thus, P of z is less than or equal to small z equals 1.0 minus 0.10, which is 0.90. And here's a picture of the normal distribution table. If you go all the way down to 1.2 and go over to 0.08, you're going to see that the total is 0.8997, and go one more over, it's going to be 0.9015, and your value is going to fall right in between there, and that's going to be the 0.90, and basically you're going to get that the z value is 1.28. And we're going to bring back the equation again. Now that we have all the values needed to solve for x, we're going to go ahead and plug them into the equations. So for the z, we put the 1.28 that we got from the normal distribution table. We're solving for x, so it's 1.28 equals x minus the mean, which is 505, all over the standard deviation, which was 110. After you complete that equation, you're going to get a total of x equals 645.8, which we're going to round to 646. And that 646 is going to be our solution. So we have determined through the normal distribution table and the equations that a student must score a 646 or higher to score in the top 10%.